So last time I left with you with a little bit of humor, um, courtesy of Snoop Dogg over here. So we're going to actually go and we're going to perform some of these tests. So we're going to perform a one mean z test using a calculator. So I'm going to go and do both as we're going through each step so that you can see exactly what your calculator is doing. So our assumptions for a one mean z test are that we have a simple random sample. It comes from a normal or large sample. Remember, large sample has to be greater than 30. And sigma is known. Of course, this is kind of unrealistic. And we'll move on to t-tests next time. So if we write down our null and alternative first, it's always what we do, H naught and our HA, before we get started on doing any test. This is extremely important. So I want to do an example while we're doing this. So let's do an example about men's heights in the world. So let's say that I know that the average world men's height is about 172 centimeters. So I know that. Sorry, I wanted to be sure about something. So their height is 172 centimeters, and the standard deviation for men's heights, so our sigma, is given at 7 centimeters. So 172 centimeters, it's about 5'7.5", 5'8", something like that. It's about 5'7.5", actually. So that's the world average male's height. Now, let's say that I go out and I sample 50 men in the United States, and I get an X bar of 176.4. Again, sigma of X of men's heights is 7 centimeters, and I get an N of 64. So I want to know, do we have enough evidence to say that the average male height in the world, or the average male height in the United States, differs from the world average of 172? And that's where we put our null and our alternative hypothesis. Remember, the null hypothesis has our equal sign. The alternative hypothesis is does not equal to, because I want to find out if they're different. I'm not really concerned with if men in the US are taller, although that is definitely something that I could do. That's not what I'm doing in this case. Okay, so what we're going to be doing in your stat is we're going to be inputting this. Now, before I do that, I kind of want to take a look at what the calculator is going to be doing. So what the calculator is going to be doing is first it's going to give you a test statistic. Whoops, that doesn't look right. Z. Now, Z, remember, that is the standardized form of X bar. So it's X bar minus mu naught over sigma over the square root of N. So in our case, that's 176.4 minus mu naught is our hypothesized mean of 172 over 7 over the square root of 64. So we have 4.4 divided by 7/8, which is 0.875, I believe. So let's see what that equals. So 4.4 divided by 0.875 equals. So our test statistic is 5.029. So we have a test statistic. We could use our Z and we could find our p-value just like we did before. Or we can use the calculator to do the entire test. So when we do that, let's bring up our calculator here. So I'm going to put it right here. So we input either data or stats. So I'm going to go to stat, go over to tests, And right now I'm just doing a z-test. So this is the first thing we do up at the top, z-test, enter. So do I have data or statistics? Since I'm not given all of 50 pieces of data, I have statistics because I have the X bars and things. So then I hit enter to make sure it takes. Then my mu naught is 172. Okay, my sigma, the given population standard deviation, I'm calling that 7. X bar, my X bar was 176.4, 176.4. My N was 64, and I want to know if it's different from. So I'm going to calculate. So look at this. I get my 5.0285. That's the same number that I came up with before. So let me go to this next page. Go on to this one. Whoops. So this is the output. So in the output, the first thing that you see here is your alternative hypothesis. That's why I always want you guys to write your null and alternative before you go about performing the test. Z is your test statistic. P is your p-value. So you notice this particular p-value is in scientific notation. I wrote that here. Be careful here. This number might be in scientific notation. It has to be less than 1. If it looks like it's more than 1, so if I glanced at that and said, oh, it's 4.95. No, it's not 4.95. It's 4.95 times 10 to the negative 7th power, which means this decimal point right here is moved back to the left 7 times. So that means I'm going to have 6 zeros, 495. That's your p-value. So you want to be really careful when you get these p-values reported. If it's something that looks like this, you're going to have to do this. So you have to report your p-value. And again, you have to report your test statistic. So my test statistic in this case is 5.029, we'll call it. And my p-value is 0.000000495. Now we know this is a really small p-value. What do we do when we have a really small p-value? When we have a really small p-value, we're going to compare it with our significance level. I didn't really give you one in this particular instance. We'll say 5% then. And the p-value is less than our significance level, you're going to reject. So what we're going to say over here is we reject the null hypothesis. Okay, the average height of males in the US differs from the world average height. So we reject, and then we're going to write a conclusion. So in this case, we have sufficient evidence to conclude, and I'm going to say exactly what I just said, that average height of men in the US differs from the world. From the average men's height in the world. So now we know this. Okay? This is why I really want you to write this conclusion, because it's one thing just to be able to do the math. It's another thing to, what is the math actually telling you? Well, in this case, the math is actually telling us that men in the United States have a different height than the average man in the world. Now, it doesn't mean that any man in the United States, there's going to be a man in the United States that's shorter than another man somewhere else in the world. But the fact of the matter is that the average height for men is higher in the United States than the average height in the rest of the world. Now, if I wanted to do that one-tailed test, so what if I wanted to do this? If I want to know, if it's strictly greater, then the only difference I would have done, go back to my test, is I would go, okay, I would go down to this last one and change this to greater than. So right now it's on that one. I click over twice. And when I'm over at that one, notice it's flashing. Now, if I went down right now to calculate, you'll notice this is still on not equal to. So I have to make sure when I go to that, I have to click enter first, then down to calculate, then enter. Now, if you see this very top right here where my cursor is, you will see that it says mu is greater than 120. That's my alternative hypothesis. Notice the p-value is changed. It's half of what it was actually, which is what it should be. And then of course it gives you your x bar and your n. This is just nice to make sure you've not made any typos. So now let's talk a little bit, well, next time we'll talk a little bit about when sigma is unknown. We're going to do lots and lots of practices of these that we just did, and then we'll talk about what happens when sigma is unknown, which is much, much more likely. So that's my preview for the next one.